All right, we've talked about columnar architecture, how this columnar approach leads to each column having almost a dedicated type of index, an area where like values can be stored and compressed for high-speed reads and analysis. We talked about the significance of choosing an appropriate data distribution style and how AWS uses this style decision to approach population of your compute nodes and node slices. We discussed the potential for massively parallel execution across these slices that each have dedicated compute, storage, and memory resources that can then work together in a linear scale-out fashion, all the way out to petabytes. Let's close out this module with a quick review of the network architecture. Another thing that makes Amazon Redshift so fast, and something that's just good to have a basic understanding of. First and foremost, remember that the only node any client can interact with in your Redshift cluster is the leader node. There is no direct access to any compute nodes or any of their resources. Now, this is good for both speed, but also security. The compute nodes are all contained within a private, high-bandwidth network within AWS. Per Amazon documentation, they also take advantage of close proximity to ensure fast intra-node communication. The nodes communicate with the underlying storage system with low-level, high-performance I/O encryption. All data is encrypted at rest and during intermediate steps. This low-level approach to at-rest encryption is done to ensure low-latency reads and writes while offering security for your data. All of this with very high throughput. The leader node, acting as the interface for the entire cluster, it communicates with the external resources such as your VPC using high bandwidth internet, or if configured with enhanced VPC routing, a network that is private to your VPC. Each of these options offering high bandwidth, low latency communication. So when it comes to the potential for network latency, it's really when the further your data gets from AWS where the larger effect for latency might actually occur. At the cluster, within your VPC, across storage of S3, and when communicating with other data repositories in AWS, it's rarely a concern. Loading from an external resource such as an on-premise data center or basic internet connection from a remote office, this is where you should focus the efforts of minimizing the impact of network latency, of which a perfect example is when doing data loads, which just happens to be our next module. High-performance data loading is our next topic. I hope to see you back for Module 2.